I'll make sure you. Questions on the homework before we start? Number 8.
I got you.
So we're given 2 points. Now to find the slope, we do y2 minus y1 over x2 minus x1. And really, I just need to pick one of the y values to go first. So I can say 300 minus 180 over 3 minus 5. Now at this point, you can type the whole thing into the calculator and let it do it for us. Right. If we do it by hand, we get 120 over negative 2, which is indeed negative 60. Now if we interpret the slope, we would say that the pool is decreasing. 60 cubic feet per hour, decreasing its volume. Its volume.
Decreases in volume?
Mm-hmm. Decreases volume 60 cubic feet per hour. Because I just need to put something in talking about the volume.
So I wrote for every hour the pool goes down 60 cubic feet.
Yes. Mm-hmm. This is more just the shorthand, kind of MPH is miles per hour. And the reason it's cubic is because volume is talking about cubic units.
So on that part, as long as you can tell that we get it.
That you are stating what the volume, or not the volume, but the slope is telling us in some way, shape, or form. Because we could say that the pool's volume is decreasing 120 cubic feet per 2 hours. Same thing. Now we need to find the equation. Y minus y1 is equal to m times x minus x1. Well, I know the slope is negative 60. Now I just need to pick one of the points, either 300, or 180. Which one do we want to use? So 300 would be the y, and 3 is our x. We're just picking the first point. Now we just need to get y by itself. So we multiply through by negative 60. So we get y minus 300 is equal to negative 60x plus 180. Now at this point here, we can add 300 to both sides. Minus y is equal to negative 60x plus 480. Okay. Any other questions on this here? We good with this here? Okay. What we're looking at today is systems of equations. We're continuing on the note sheet from yesterday. Now, luckily for us here, luckily for us for this problem here, what we're doing first is picking a variable to eliminate. Now, the 3 variables that we have, x, y, and z here, there's not really one that's not as good to pick. Because yesterday, when we looked at the one that we had, z was not as helpful because it was harder to get it to be one of the other 2. And if we look at this one here, if I look at x, well, the top one has 1x, yes? I can easily change it into 5x or 4x by multiplying it by 5 or 4, respectively. We look at y. Well, the top one's 1y. The bottom one is 1y. Those are already the same. So I need to pick an eliminator equation, multiply it by 5 for it to be the same as the middle. Questions on this so far? So we can see x and y, we can use one of those to get it to be the same as the others to cancel out. And if we look at z, well, the top one is 1z. I can change it to 3z and 5z and get those to eliminate as well. So realistically, x, y, and z, all of these would work well for the first one. So the key is, which one do we want to eliminate first? Y. So we'll eliminate y first. Now we need to pick an eliminator equation. We can use the top one or the bottom because both of them are 1y. Which one do we want to use? So we'll pick this as the eliminator equation. I didn't state this yesterday, but part of the reason I highlight that is just to remind myself, this is the eliminator equation, the one I'm going to use to eliminate y out, so I don't use it twice. Now at this point here, we can write the other two equations down. So we have these here. Now we chose to eliminate y first. So we have x plus y. What do we need to multiply this equation by to get the y's to be the same for the one on the left? 5. Because if I want 1y to be the same as our 5y, I need to multiply the whole thing by 5. So here we can distribute the 5. 5 times x is 5x. Plus 5 times y is 5y. And lastly, 5 times z is 5z. And on the other side of the equal sign, 5 times 2 is 10. And I'll put it underneath. 5x plus 5y plus 5z is equal to 10. Questions on how we got to this point? Now looking at this here, to eliminate y, would we add these two equations together or subtract them? Subtract. Because 5y minus 5y is 0. So they would, since we subtracted one, we're going to subtract all of them. 5x minus 5x is, okay, incidentally, they're gone. Y's are already gone. 5z minus 5z is, so this entire side became 3 minus 10 is indeed negative 7. Is this a true statement? Because what that's telling us is the top equation and the middle equation are parallel to each other. They're never going to intersect. And if those two equations are parallel, it means we have no solution, because for us to have a solution, we have to have an intersection of all three. And if two don't intersect, there's no way we'll have a solution. Questions on this here? Now, if we did get a statement that was true, say 0 equals 0, we still need to do the other side to make sure that we don't get a false statement on the other one. Does that make sense? So if the left side did become 0 equals 0, we'll check the other side to see if we have one. Questions on any of this here? So we've now seen one that is no solution. Are we ready for the next one? Example number 3. I have to do them still. Because there's some, at a certain point, I can pick up on it, but I still need to work it some way through, because it's sometimes hard to tell. Now this one here, we need to figure out if we're eliminating x, y, or z first. I would agree. Because what is the number in front of z in all three places? 1. We have positive, negative, but it's all 1. They're already the same, yes? Yeah. If there's a variable that has the same number in front of it for all three, regardless of sign, it's the same number, I pick it. And then I'm just going to pick the middle one as our eliminator equation. It doesn't matter which. And then I'm going to write the other two. So we have x minus y plus z is equal to negative 3. And we have 5x minus 5y plus z is equal to negative 15. But since the number in front of z is already the same, we don't have to do anything to it. We don't have to multiply it by anything. So I can just rewrite x minus y minus z is equal to negative 3. And x minus y minus z is equal to negative 3. I can go on and fill both of those in. I don't have to do anything to it to get them to be the same. Questions on this so far? Now to cancel these out, to cancel z out, positive z and negative z, we would add or subtract. Z minus negative z. 1 minus negative 1 is? 1 minus negative 1 is 2. So we add. If the signs are opposite, we add. If the signs are the same, we subtract. Since one of the z's is positive, the other is negative, we're going to add. And if we add these together, x plus x is 2x. Negative y plus negative y is negative 2y. Z plus negative z is 0. And lastly, negative 3 plus negative 3 is indeed negative 6. So we have got an equation with two variables this time. Let's look at the next one, 5x. So we would, again, add. I don't know why I started reading the equation. Because the main part is z plus negative z is 0. Now if we go with the rest of them, 5x plus x is negative 5y plus negative y is negative 15 plus negative 3. So just like the first one we did, we now have two equations with two variables, yes? Which one do we want to eliminate next? We'll eliminate y next. Now we always want to increase, if we can. Is there a number we can multiply 2 by to get to 6? 3. Okay. So since we can just multiply one of the equations by a number and get them to be the same, I don't have to do anything to the one on the right. So I'm going to write it down.
Is it negative 18 or
Negative 18, yes. Our other equation, 2x minus 2y equals negative 6, as y'all said. We're going to multiply the whole thing by 3. 3 times 2x is 6x. 3 times negative 2y is negative. And negative 6 times 3 is negative. Yep, that first one should be negative. Yeah. Now will we add or subtract? Are the signs the same or opposite? Yeah. So we would subtract. Because our negative 6y minus negative 6. Yeah, so the 6y and 6y do cancel, yes? What's 6x minus 6x? This entire side is 0. And negative 18 minus negative 18 is 0. Is this a true statement?
Yeah.
Infinitely many. So there's infinitely many solutions that work for this here. I'm not going to make you go through the process of actually finding the equation that defines this. We're just going to call it infinitely many solutions. It's out there. Any questions about this here? Okay. All right, so I did find this today. I did add this to the teacher webpage. I don't know if y'all know how to get there from the teacher directory on Colcord Schools. If you go to Colcord Schools High School directory that has all of our names, our pictures for the staff. If you click on it, I do have some of these resources up. Now this one here, what it lets us do is actually graph a 3-variable equation, or a graph in 3 dimensions. 5x plus 5y. No. So this here's the last one, the one that we said was no solution, yes? Those two blue planes, do they intersect? Well, no, we can see that they're parallel, yes? This is why we got no solution, because there's no point between those two or anywhere for those two that they actually cross or intersect. Now the one we just did, we had this here. So this here is the one we just did. So we can see that they all three do intersect, but they intersect in this kind of, not quite an X, but they all have a line where they do intersect. And that line, if we went and found the equation of that line of intersection, would be the solution for the set of infinitely many solutions. So any point that lies on that line would be true. So I'm showing you this just so you can see graphically this is what it would look like for the graph of this infinitely many solution.
Do they all look different?
A little bit in how they intersect or work. Because if it is a single point, there's only going to be one spot where they actually cross. We won't have this kind of line. And it works out that they're intersecting on the plane, that gray plane is the z-axis. So z is actually 0 for all of them. The x and y are actually changing. All right. Well, we don't need that anymore. Yes. Let's look at the next one. Now, looking at this problem, the first thing we need to determine if we're going to eliminate x, y, or z first. Why? Because the value for each y is all 2. They're already the same. If one of them's already the same, that's the one I'm going to use because it makes things a lot easier. Now, which one do we want to use as the eliminator equation? Middle. Since it's the eliminator, we can write the other two first, x minus 2y plus z is equal to negative 11. We'll also have negative x plus 2y plus 4z is equal to negative 9. Okay. Looking at the one on the left. We can add. Yes. Because we want to get the y's to cancel, yes? So going left to right, x plus 3x is 4x. Negative 2y plus 2y is 0. Because that does work. 2 minus 2, negative 2 plus 2. Lastly, z plus negative z. And 11 plus 7 is? Negative 11 plus 7 is? Negative 11 plus 7. Negative. So we have 4x equals negative 4, yes? We can already solve for x. Yes, it's by itself. Go on and solve. I can divide both sides by 4, telling me x is I already have a third of the answer. Because there are going to be some times where we do one of the elimination steps and it eliminates 2 of the variables out, and we're left with 1. Let's look at the other side. So we're eliminating y, yes? Are the signs the same or opposite? Same. So we eliminated y. That was our purpose for the first one. Because if we wanted to eliminate z, we would have to do something to the equation in red. Forget them to match, because numbers need to match. So we'll subtract. Now, negative x minus 3x. Negative 1 minus 3 is negative 4x. 2 minus 2, 0. 4 minus negative 1. Well, the negative makes a plus 5z is equal to?
Wait, it's negative x minus 3x. Isn't that positive 4?
So negative 1 minus 3.
Wait, what? Okay.
If it was the other way around, 3x minus negative x, then it would be. And lastly, negative 9 minus 7 is negative 16. Right, and keeping track of some of the negatives when we're doing this by hand, it might be helpful to type it in the calculator as you see it going top to bottom and let it deal with it for us. Questions on this so far? Well, after doing one elimination, we have one equation that's already simplified, yes? And we have another equation with 2 variables. But this equation with 2 variables, do I know one of the values? Well, I can replace x with, well, now I can solve the equation for z. Negative 4 times negative 1 is? 4. Exactly, at this point we would. Minus 5z is equal to negative 20. And last but not least, we would divide by 5. And the z is negative 4. questions on how we found x and z? Well, to find y, we just have to plug it back in one of the original three equations. Any questions on this before we find y? Now, do we want to solve for y using the top, middle, or bottom equation? We can do both. Yeah. Because if we use the middle, it's going to be 3 times negative 1 plus 2y minus negative 4 is equal to 7. 3 times negative 1 would be negative 3 plus 2y. Our negative 4 would be plus 4 is equal to 7. Combine like terms. 4 and negative 3 gives us positive 1. At this point here, we can minus 1 from both sides. 2y is equal to 6. Divide both sides by 2, telling us y is equal to. So our solution is the point negative 1, 3, negative 4. Questions on this here? Do we feel better about these today than we did yesterday? Yeah, we can. All right, let's do number 3 because number 2 is a no solution. So let's look at this one here. Do we want to eliminate x, y, or z first? Which one do we want to use as our eliminator equation? Top, middle, bottom? Middle. Yeah. Well. Okay. Since we're using the middle one as our eliminator equation, we can write the other two. X plus y plus z is equal to 8. 2x plus y plus 2z is equal to 16. Now the nice thing with this one is the number in front of y in both cases is already 1. Now the signs are opposite, and that's fine, but I'm more focused on the number being the same, that they're both 1. Now looking at the one on the left, will we add them together or subtract them? Add, because the signs are different, positive and negative, because y plus negative y is indeed 0. And what that leaves us with is x plus x is 2x. Z plus z is 2z, and 8 plus 8 is 16. We now have one of our equations with two variables. Let's look at the other side. Will we add or subtract? Add again, because these signs are opposite for our y's. 2x plus x is 3x. Y plus negative y is indeed 0. 2z plus z is plus 3z. And 16 plus 8 is 24. Questions on any of this here? Now from here, do we want to eliminate x or z next? Well, is there one that works nicely? No. So we're going to have to do two multiplications. So we can choose x, and what we can do for this here is I'm going to multiply this entire equation by 3. And I'm going to multiply the other equation by 2. Because I'm wanting to get the x's to be the same. And if we distribute this 3 times 2x is going to be 6x. 3 times 2z is going to be plus 6z. And 16 times 3 is 48. Do the same thing with 2. 2 times 3x is 6. 2 times 3z is 6z. And 2 times 24 is, what do we think the answer is going to be? Infinitely many, most likely. Now at this point, we need to put them over the top of each other. Yes. Now will we add or subtract? Because the signs are the same. Because 6x minus 6x is 6z minus 6z is, that whole side became 0. 48 minus 48 is infinitely many solutions. And that's it. Yes, there will be some with one solution if we actually get values for x and y. They don't just cancel completely out. And that's it.